Hello friends, warm greetings from Tech Expert and welcome back to another episode of Laptop Repair. So today we got a laptop for repair and this laptop we received from another repair shop. So the problem with this laptop, it turns on but it does not give display. So now let us diagnose it thoroughly and find the problem that is causing for this laptop to not to execute the display. So without making any delays, let's get in. So here we have only the board and the display here so that we can check with the motherboard whether it is getting the display after we have solved the problem. So the repairman only gave this motherboard and with the display. Now you can see the power supply display on the screen now. So now I am going to connect the adapter into the DC jack here. So watch out for the ampere readings on the power supply. Yes, the fan is spinning. The ampere got around 700 milliamps. Okay. Now let me see whether I am getting the display. No, I'm not getting any display here, but the ampere is reading around 800 milliamps right now. Still there is no any displays. Okay, now let me try to swap the RAM slots. Swap the RAM modules in the different slots and see whether I'm getting any display output, just in case. Okay, now I will reconnect the adapter. Let's see the ampere reading. It's same as before, 700 milliamps. Fan was spinning. Still it is stuck at 700 milliamps. Yeah, it's 76. So 820 milliamps. Am I getting the display? No, I am not getting the display. The ampere is still at 800 milliamps and no changes. But right now we have got the voltages of the CPU, I guess, because at this type of current consumption we should have got the voltages for the CPU. So there is something is making for the CPU to not to execute the display. So we have to check that. Okay, I am getting something. So the RAM voltage is present. Yes, 1.5 volt. And also the CPU voltage is also present. So let me go from the basic checkups, from the diode checks. Then I can go straight to oscilloscope testing the voltage rise in the sequence so that I can capture the first sequence of the voltage rise when the board turns on, so that in that case we can identify the problem that is causing for no display. Not always. In some cases the no display cases can be due to the signals that are not present, the crucial signals that are not present on the motherboard. So we don't know anything about that. Anyway, we will follow a basic steps. So first from the diode check and then back with the oscilloscope reading on the coils each coils, and then we can move on to the signal testing on this motherboard, so that we can find whether we can solve the problem. Okay, now let me tell you the model number of this laptop. So this model number is here, HP ProBook 4530S. So this is a ProBook laptop of the HP, and when you look at the part number of this motherboard, so it's 6050A2408801. So most probably when the motherboard's part number starts from 6050A, which means this motherboard is produced by the Inventec motherboard producing company. The starting point is at this point. So first the adapter voltage comes into this point and goes into this inductor here, and then out from this inductor goes to this first MOSFET. So this is the main MOSFET. Then it goes to the second MOSFET here, and after that it goes to everywhere around the board. So it goes from here to this point here, which is the current sense resistor. So we can check with the continuity mode in order to confirm they are connected between each other. So you can hear the sound now. Yes, so you can hear the sound. So they are connected to each other. So this is the second MOSFET, and this is the current sensing resistor. So now we are going to start our diode check from this point. So negative probe on the current sense resistor, and I am going to place my red probe on every coils. So the reading 500, okay, 494, okay, 525, okay, 494, okay, 494, that is fine, and 510, that is also fine, and 531, that is also okay. Now we are going to check with regard to ground. So I am going to shift the probes. Now positive probe back to ground, and the negative probe on the coils in order to check the lower MOSFET. So 541, 65, okay, 15, actually it is 0.015. so you can see on the multimeter it's 0.021, and this is 0.064, and this is 1.56, sorry, it's 0.156. okay, so when you look at the core sections, the supply for the CPUs, so the coils beside these beside the CPU will have a low resistance when you check the diode value for the lower MOSFETs, so that is normal. But when you look at here, this is the 5-volt coil of this motherboard, and this is the 3-volt coil of this motherboard. So when you check the diode value at this point here, it is showing 157, that is okay. But when you look at this point, it is showing 64. So this is a bit lesser than normal. But anyway, let us keep it as it is. Let us check and come back. Okay. Okay, let me see the ohms value in this point here. If I turn to ohms mode, it is 36. What is the ohms value at this point? So it's 0.8 kilo ohm, 800 ohms, and it is 36 ohm at this point. So way more lesser than this one here. 3.3 volt is higher resistance. The coil on the 3.3 volt is having a higher resistance, and the coil on the 5 volt is having a low resistance, so we have to check these points. So we are blessed with the jumpers here, so we can remove those jumpers and isolate the sections and identify the area that is causing for this coil to show low resistance. Okay, now I will plug in the adapter and check if I am getting these voltages. I'm sure I will get voltages because I am getting the board turning on, so it is fine. Okay, I think I can go straight to the oscilloscope checkups rather than just checking the voltage, because up to core voltage, the CPU voltage I'm getting, so there won't be any problem with the 5 volt and 3 volt power supply here. The standby supply should be generated in order to get the CPU power supply. So therefore I guess this should be present when I plug in the adapter. So in order to check this, anyhow I will check with the oscilloscope if there is any fluctuation in these coils. Okay, now you are able to see on the display the both screen of the oscilloscope and the power supply. So now I am going to check with the oscilloscope with the single second function set. So now I am going to use the trigger function in order to identify the first sequence of the voltage rise, so that I can detect if there is any fault in the regulator side. Okay, now I'm going to set the trigger value up to 1 volt so that I can check the voltage at the CPU core section, the regulator side. I will reduce the voltage. Okay, the trigger level. Okay, everything is set. Watch out the screen of the oscilloscope. Yeah, we do have some fluctuations on the line. Yes, it's clear, it's clear. Yeah, there we have the fluctuations. Okay, so we are going to do the same that we did earlier for that problem. So we replaced a coil and then we replaced a capacitor and we solved the problem. So in this motherboard also it might be the problem, but I'm not sure. Okay, right, before changing the capacitor, I will just check the capacitance value with my multimeter and see whether they are in its range where it should be. So when you look at these capacitors here, so these capacitors are 420 microfarad capacitors, so they should read around this range with the multimeter, so I can check whether they are good or bad. Okay, so we are getting a high capacitance value. So because the capacitance are in parallel to this one, because there are many capacitors around the area, so they might be in parallel, so we are reading the same value. So I'm thinking to replace this coil here first and go with the capacitor after, so that will be a good measure, because we have many capacitors here, so we can't decide which to replace. So we will first replace these coils here and check if we are improved with the voltage rise with the oscilloscope. Okay, Okay, so now I have two inductors with the same value. It's 36.36 microhenry. Both of them are 0.36 microhenry. So now I will replace them in this place and see. Okay, so the inductor is well fixed in its place. It looks fine. I'll just clean this later. I'll reset the oscilloscope so it's in the same trigger mode. Okay, let's see for the change. No, we don't have any change. It's similar as before. There's no any change. So I guess there's no problem with the inductors. So there's no problem with the inductors, I guess. So I'm getting the same reading as before. But if you look at the oscilloscope, so we are not having a proper PWM signal here. I'm getting the same reading on both sides. So let me show you on the other sections PWM. So this is not the PWM. So if I place it on this side, yes, this should be the PWM signal. So this is on the 3 volt section, the coil voltage, the standby voltage. So this is the correct PWM. So you see, yes, this is the one. This is the correct one. So we should have a bars at first, then we have like a spring waveform. You see, a bar, then after that we are having a spring waveform. But on the inductor of the CPU, we are having only the bars. There is no spring waveform, only the bars. So this is not appropriate. Let me check on the 5 volt coil output. Yes, we do have a proper signal there also. That is very nice. Okay, on the inductor side, on this side, this is for, I think this is for the GFX voltage maybe. The graphics card inside the CPU is supplied with this voltage maybe. I'm not sure, I have to check with the schematics. Okay, this is also looks fine. Oh, I'm sorry, actually this is not the GFX voltage. I think a coil on this side here, this should be the GFX voltage, because the GFX voltage will not be generated if we are not getting the display. So this might be some other display, some other voltages that provides an auxiliary supply for the CPU maybe. So we have to confirm it with the schematics. On the other side we are having the RAM supply coil. Let me check that. Yeah, we do have a proper PWM signal on this side also, on the RAM coil. So we having a bar, and then after the bar we are having a spring waveform. This is appropriate, very nice. Okay, now there's a problem in the CPU core section. we need to find a solution for that. So either we need to replace the regulator IC, or else we have to replace the MOSFETs. Sorry, the MOSFETs, we have to replace the MOSFETs, or else we have to replace the capacitors. So let's try one by one. Let's see. So before moving on to the replacing the regulator IC of the CPU, and also replacing the MOSFET, and again replacing the capacitor, so I have tried to check the entire motherboard based on the sleep states such as S3 signals, S4 signals, and also the run power and suspend power, and check everywhere in the motherboard whether everything is fine. So up to now I have checked all the power planes in this motherboard and they are working good, and I have checked all the power good from each of the regulators and they are high and they are working okay, so there is no problem. So then I decided to check on the RAM side, on the RAM slots, so we can check the DRAM reset on pin number 30, and we can also check the system data and system clock line. So the system data and system clock line is on the 200 and 202 pin of this connector here. So we can check the system data and system clock also. So I just found that when I connect the RAM in this slot and power on the board, I'm getting the same ampere. When I remove the RAM module from this socket and turn on the board, I'm getting the same ampere. So which means the RAM is not detected. So now I will show you that the ampere reading with the RAM attached to the board and also without the RAM attached to the board. Okay, so now you can see the display of the power supply in the screen. So now I am going to connect the adapter here. So now I have not attached the RAM in this module, the slot here. So you can see the ampere reading is around 700 milliamps and the board turns on. So, and it will reach up to 800 milliamps. Let's wait for it. Yes, now you can see the ampere reading is at 800 milliamps. So now I will disconnect the adapter and attach a RAM module in this one of the slot. Now I will connect the adapter and let's see the ampere reading. So the ampere reading is same as before, there is no much change. It is fixed with the 700 milliamps approximately. It will go up to 800 milliamps and it stays still. There is no change with the current reading. So what we can do is we have to do the checkups on these RAM slots. So how does the CPU or the PCH detects whether the RAM is connected to the board? So it is detected through the SMBUS line. So there are two pins that is going into the RAM slots here, which is known as the system data and system clock line. So this line reads the RAM module when it is connected to the board through the EEPROM chip on this RAM module and gives the information about the RAM back to the CPU, back to the PCH here. Then the PCH will give information to the CPU. Then the CPU will communicate with the RAM and initiate the display. So if there is a problem with the communication of the SMBUS line from this point to here, so there won't be the identification of the RAM whether it is connected to the board or not. So in that case we will not have a detected RAM and the display will not be executed. So basically we can check this with the multimeter, but for advanced checkup we have to use the oscilloscope to read the waveform and identify whether there is a data going through the SMBUS line for the PCH to detect that the RAM is connected to the board. And also we need to check pin number 30 in the RAM slot in order to see whether there is a DRAM reset signal. So the DRAM reset signal is very crucial for the CPU to initiate the communication between the RAM module. Okay, so now we are going to check the DRAM reset on pin number 30, and we are going to check pin number 200 and 202 to check up the system data and system clock line. And additionally, we also need to check the VTT voltage in this RAM module, because the VTT voltage is the voltage that is supplied for the network connection with the CPU and the RAM banks in this module. So these small chips are known as banks. So these banks are communicated with the CPU through the network of connection. So the voltage for the network connection is known as the VTT, that is half of the RAM supply voltage. So if it is in this case, so it is 1.5 volt, and we will getting 0.75 volt as the VTT voltage here. So we need to check that voltage also in order to find any problem with the RAM section. Okay, now I am going to connect the adapter. The adapter is connected and the board has turned on. Now we are going to check the DRAM reset at pin number 30. So the DRAM reset is at pin number 30. So this is 10, 20 and 30 here. So we are getting 1.5 volt. So DRAM reset will be always the RAM supply voltage. So it will be 1.5 volt in the case of DDR3. And also we need to check the system data and system clock line. So that is on pin number 200 and 202. So it's here, pin number 200. So we are getting 1.4 volt. So we should not get 1.4 volt at this point. So the pin number 200 is the system clock line. So the system data line. The system data line should show 3.3 volts. So 1.4 volt is not appropriate. So let us check other pin 202. So yeah, this is okay. This is 3.4 volt. So approximately we will find around 3.3. So 3.4 is okay. So we are missing 2 volt in system data line. So I think this is the problem. So if we are not getting the voltage, the correct amount of voltage, so we will not be so there won't be any communication or data transfer between the RAM module and the chip and the PCH here. So the RAM will not be detected. So now we have to face the problem that is causing this 1.4 volt, to come. Okay, so now we are looking at the RAM module section in the schematics of this motherboard. So we are getting 1.4 volt at this pin here, at pin number 200, which is the system data line. Yes, the signal name is PCH_3S SM data. So we need to find that signal name. Yes. So it's going to various places around the motherboard. So we need to find which is causing this problem. So here's a chip. So it's a bidirectional communication from both sides, from the RAM side and also from this chip side also. So that's all. So there are only 5 sections that is having the same signal names. So if you look here we have 3 volt run power supply, which is supplied through these resistors back to this line. So I need to first check this R416 and R419 and check whether they are appropriate in their size 2.2K. So if the resistance of this resistor increases, there won't be the proper voltage 3.3 volt in this line. So when this resistor increases, the voltage in this line will be reduced. So we need to check first the R416. Okay, so it is very difficult to find these small resistors in this motherboard because we don't have location of these resistors in the motherboard, and also we don't have board view of this motherboard. We have the only option to identify this Q57 so that we can find the resistors nearby this IC, this chip, so that we can find the voltages on the top side and on the bottom side. So let's find Q57 in the motherboard so that we can identify all of them. Okay, so here we found the Q57 IC in this place, and we have the resistor here. So this is the pull-up resistor that gives 3.3 volt supply into this data line here, and also there is another resistor, I think this one or this one, which supplies the same 3.3 volt run power supply into this data line. So this data line comes to this chip and come out of this chip through this line here. So we are going to check these two resistors whether their resistance are appropriate. So the schematic source, it should be 2.1 kilo ohm, so it should be approximately in that value. So I'm probing one here. Yes, it shows 2.2. that is okay. That is okay. The other one here, that is also okay. So now I am going to plug in the adapter and see what is the voltage we are getting in that line. Okay, now I have plugged in and the board turned on. So let me see the voltage. On one side, yeah, I'm getting 1.4 volt. On the other side, I am getting 3.3 volt. So this is the pull-up voltage for this resistor, and the on other side, so we are getting 3.4 volt and we are getting 1.5 volt. So totally the data line is having a problem, that 3.3 volt is not stable there. So now what I'm going to do is I'm going to separate the sections which has the same data line receiving and transferring. So one by one I'm going to remove this chip, remove the sections and ICs that receive this data line signals, so that we can see whether the voltage has been risen up to 3.3 volt. Okay, so now we are going to start from this point here. So this is that Q57 chip here. This is the dual n-channel MOSFET. So we are going to start isolating the system data line from wherever it goes except the PCH. So after removing or isolating all the sections that is in communication with the SM data line, still if you are having that 1.4 voltage, then that is a problem with the PCH. So we can't solve this board hereafter due to the less voltage from the PCH. So some components inside the PCH would have been damaged. So that is the thing which is making the voltage for this system data line to drop below 3.3 volt back to 1.4 volt. So let's isolate the areas one by one wherever it goes and find for a solution. So let's hope for the best. So first I'm going to remove. So I can remove either this chip here U521, or I can remove these two resistors from this line here because it is the one that is connected to this data line. So just removing this chip, or I can remove this resistor here. Okay, so here we have the chip U521. Let us check the voltage at the pin number 7. Let's see whether we are getting the same voltage reading on the data bus line, that is 1.4 volt. So now I will connect the adapter. No, it's 3.4 volt. So you can see I am probing at pin number 7, but still I am getting 3.3 volt. So which means that this line is not connected with that line, which means on the data bus line that we saw it's 1.4 volt earlier, so this line is not connected with that line, so there's no problem in this chip here, so we leave at it as it is. Okay, as you can see, it says it's open, which means it is not connected in this chip here, so we can move on to other section. So it is just a connector, so there is nothing going on here. So this is back to the RAM slot, no problem, the other RAM slot here. So this is back to that N channel MOSFET here. Okay, yeah, this is the last thing, and we have reached to everywhere where the system data line is traveling. So we have the last option here, so we should remove this U2 IC and see whether we are getting the 3.3 volt in this data line. So if we are not getting this voltage, then we can't solve this motherboard unless we replace the PCH. Okay, so now we found the U2 chip. Now you can see, so this is the U2 chip. So now we are going to remove this chip and see whether we are getting the 3.3 volt back in the data line. I don't know what this chip doing here. First of all, I'll just check whether we are getting the voltage higher up to 3.3 volt. Okay, now we have removed the chip. So the pins are very small, which is inside the chip. We can't see that outside. So it's very tricky if you want to replace it here. Okay, anyway, let's see for the result now. Let me cool down the board. Now we need to check at this point here the voltage at Q57, and we can find near the resistor whether we are getting the voltage on 3.3 volt. Okay, so now I am going to connect the display. Sorry, now I am going to connect the adapter. So before that, I will place the heatsink of the PCH back in place. Just to make sure it is not overheated. Okay, now I have connected the heatsink. I will connect back the RAM slot, or just I will check the voltage first and then we can connect it. So now the display of the power supply is visible to you. So now I am going to connect the adapter. So we have not connected the RAM module in the board, so we may not get any high current reading. Anyway, we can check the voltage at system data line, whether we are getting whether we are getting 3.3 volt in its place. Okay, so I will check at this point. So on one side we are getting 3.3 volt. Yes, on the other side also we are getting 3.3 volt. So after removing that IC, so we were able to get the voltage back in this point. So we were checking the voltage in this resistor earlier, as you can see. So we were checking the voltage in this resistor earlier. In this side we saw it was 1.4 volt. On this side we saw it was 3.3 volt, but now we are getting 3.3 volt on both sides. And let me see the voltage in this resistor is also. So we are getting 3.4 volt. Okay, on the other side 3.4 volt. So okay, so now we have managed to bring the voltage of the system data line back to 3.3 volt from 1.4 volt. So now I will connect the RAM module in the board, and let's check whether we are getting the display or whether we are getting the RAM reading by the board. So we should get a higher ampere reading on the DC power supply, which should be above 800 milliamps. So then only we can confirm that the RAM is detected by the board. Okay, now watch out the display of the power supply. Now I am connecting. Yeah, you can see it's taking 1 milliamps. So we have done the work. So now I will connect the keyboard just to make sure whether we are getting the lights. Yes, we have solved. Now you see here we are getting the display here. Oh, it's turned off. Yeah, it's turning on again. Now I am pressing the lights, the number lock. Yes, we got the display. So we have solved this problem. So I'm happy that I tried to solve the problem without making any damage to the board. So we have another laptop repaired. So now I will assemble this board in the laptop and check whether everything is working. So we were able to solve the problem of no display after removing this IC from this motherboard. So the problem is actually with the system data line. So the voltage on this data line was approximately around 1.4 volt, and this 1.4 volt is pulled down by this IC here. So when this IC became internally damaged or internally malfunctioned, so this pulled down this voltage back to 1.4 volt. So that's why the RAM is not detected and there was no display. So after removing this IC, this data line was left open so that the RAM was able to communicate with the motherboard. And also we no need to replace this IC back in this place as a brand new, because this is not crucial. This IC is not crucial for the laptop to work. So this is just an auxiliary function. So we no need to replace it. So we will leave as it is. So the board will be working fine. Okay, so now I am going to show you the readings in the oscilloscope, the data line of this RAM here, so that we can see if there's any data transfer happening when the RAM is detected. Okay, now we have to check pin number 200 here. So now I will connect the adapter. Watch out the adapter, watch out the power supply, and also the oscilloscope display at the same time to see any change in the data reading. So now I am connecting it. First of all, I will fix the probe in the pin 200. Okay, Yeah, there's a reading you can see. So at that time the RAM is detected by the motherboard and it will be working fine. And the MP is also reading 1 ampere, so everything is fine. I will now check the clock of this line. So at the pin 200 we are getting the data, and on pin 202 we will be getting the clock line. I'll disconnect and connect again. I'll set the trigger. Yes, we do have the data line also. Sorry, the clock line is also there. So now it's working properly. Back on the data line. Let me disconnect the adapter. Connect. Yeah, there's a reading. We can see. So now the RAM module is now detected by the PCH and it will be communicated by the CPU. Okay. Okay, so now I have assembled the board in the casing. So we'll just see whether we are getting the display. All right. So I am going to plug in the adapter now. You can see the reading on the power supply. Yes, I have connected. Yeah, we got the display. So we have solved the problem. So we have another working laptop. So stay tuned for future videos. So bye for now.